Given the increasing interconnectedness of the world, as well as the demonstrated benefits to individuals of speaking more than one language, improving the way that second languages are taught is an area of growing importance. A critical part of this involves understanding the brain mechanisms that are involved when learners comprehend grammatical structures. However, previous brain research on language processing has typically involved artificial experimental tasks and stimuli in isolated laboratory settings that are different from what a typical language user encounters in the real world. To address this obstacle, our project harnesses advances in wireless portable brain scanning and computerized speech recognition to investigate the grammar processing mechanisms that underlie naturalistic conversation in native and second language, L2, English. Electroencephalograms, EEG, will be recorded during unscripted conversation between native and L2 speaker pairs and synchronized with transcriptions. The observed data will be compared against predictions from computer models based on different possible mechanisms of grammar. Specifically, we test hierarchical models involving nesting of abstract grammatical structures, such that a phrase like in the house involves processing the house as an internal subunit, versus sequential models based on how often words co-occur. For instance, in is often followed by the is often followed by house, etc. Objective 1 asks whether previous findings of hierarchical processing in native speaker audiobook listening also hold for social interaction. Objective 2 asks whether native and L2 speakers differ in the hierarchical versus sequential nature of their processing. Objective 3 turns to the mechanisms of social context to ask whether neural signatures of grammar processing are affected by brain-to-brain synchrony. This work informs language teaching praxis by revealing how the statistics of L2 input affect grammar learning. It also broadens participation in neuroscience by using a crowdsourceable experiment design with affordable, portable brain scanning devices. Finally, by building an open-access corpus of naturalistic unscripted conversation, the audio, neural signals, and transcriptions will be made available to future researchers to address other language-related research questions.